What if I told you that a single rock from space could be worth more than gold, hold secrets older than Earth itself, and just maybe contain the very building blocks of life? This rock has traveled millions, no, billions of years across the cosmos. It dodged asteroids, survived violent explosions, and endured a scorching descent through our atmosphere, only to land here, at our feet. Right now, this very second, another meteorite is on our way to Earth. Maybe even one that can change everything we know. Let me show you just how real and incredible meteorites truly are.
Have you ever wondered about the difference between meteors, asteroids, and meteorites? They may sound familiar, but they're actually quite different. Let's break it down. First, let's talk about meteors. These small space rocks, often fragments of asteroids or comets, that enter Earth's atmosphere at high speeds. Because of the friction in the air, they heat up and burn, creating bright streaks we call shooting stars. Next, we have asteroids. These are much larger, rocky bodies that orbit the sun. Unlike meteors, asteroids don't burn up in Earth's atmosphere because they rarely enter it. Scientists estimate there are millions of asteroids in our solar system. Mostly have found in the asteroid belt between Mars and Jupiter. Finally, let's talk about meteorites. These are similar in size to meteors, but unlike meteors, they don't completely burn up in the atmosphere. Meteorites have been found all over the world, some containing rare minerals and even organic compounds.
Meteorites are precious rock samples preserving material from the birth of the solar system 4.6 billion years ago. Now, that might sound like an eternity to us, but in planetary terms, Earth is literally a baby compared to some of the ancient worlds out there. When these extraterrestrial rocks land on Earth, they offer an extraordinary opportunity to piece together the history of our solar system's birth and evolution. But here's the catch. Meteorites don't stay the same forever. The second they crash land, Earth begins breaking them down. Rain seeps into the cracks, freezing and expanding until the rock splits. Wind and sand grind away their surfaces, wearing down their once pristine cosmic textures. Even oxygen in the air reacts with these minerals, rusting and corroding them over time. And what if that wasn't enough? Microbes, yes, tiny living organisms, began feasting on certain elements of the rock, further altering its chemistry. Bit by bit, the meteorite loses its original features, erasing clues of what it was an interstellar journey. That's why scientists race to find them. Before time, weather, and even life itself strips away the cosmic secrets they hold.
And this is exactly what museums are for. They allow us to have a place to go back in time and explore our past from a whole different lens, along with proof such as the artifacts in the several exhibitions, which allows the veracy of what is being taught to us, which takes us to the Peabody.
Hello, my name is Christian. I am from the EVO program, and I'm here to do an interview about you on meteorites. What is your name?
Hey Christian, my name is Stefan Hurlburt. I'm the lead exhibitions preparator here at the Yale Peabody Museum.
All right, so to begin things off with this interview, I have a few questions for you. My first question is, how do you prepare the meteorites on exhibit?
So with these particular meteorites, what my team's job involved was actually physically mounting them. So anything, and this applies to anything within the museum, anything you see displayed within a case that appears to be floating, whether that be off of the wall or on the deck, has some sort of structure to keep it safe and secure. So with the meteorites, we worked through a preliminary design and layout, and then from there constructed all of the mounts that you see, kind of holding them up.
Is that difficult, really, to construct each mount?
It can be. Every mount is different, and ultimately the goal of our mounts is to be unobtrusive as possible so that it doesn't distract from the piece that it's holding. Yeah. And so meteorites, for the most part, aside from some of them being pretty delicate, are fairly easy mounts. They're pretty organic shapes, especially the ones that we have on display here in this case. So nothing overly complicated in this display.
What is like the process of mounting them? Like exactly, like step by step, what do you do?
Yeah. So generally we have a design layout that we work through with the curators, with our design team, and with other members of the exhibition staff. From there, we will transfer the material over to us down in our workshop downstairs. And every mount maker kind of works a little differently. One of our mount makers, May, she tends to sketch out a rough design of his mount and how it's going to sit on the object, whereas I will kind of just work in my head and kind of as I'm moving along with the piece in most cases. Sometimes I'll do a rough sketch. But primarily everything you see here is done out of brass. That's our main medium for the mounts that we do here. And so from there, it's really just contouring the brass, soldering the brass, and really bending and shaping it to fit the object and kind of cradle it appropriately. Once the mount is fabricated, we will prime it and then paint it out. So we try to faux finish all of our mounts so that they blend in seamlessly with the object. And then every mount receives some sort of padding or intervention between the base material, being the metal, and the object surface. So most of these are all like a felt material between as a barrier. And then the next would be we do templates to help us install, and then the actual installation as well. It's
Have
kind of
there
the
been
final
any
step.
times that you've like failed, like you messed it up a bit?
With these meteorites, no, but I mean, with a lot of other mounts, constructing the mount is very, oftentimes I'll make one, finish it, and then a day later realize I could have done it completely different and, wish I had done it that way. And then with our job, we're handling this material kind of a lot differently than it typically would be. We generally need to kind of turn it, rotate it, test fit it. So things do break. It does happen. None of these did break, thankfully, but through the renovation, things broke. It's unfortunately it's the negative part of our job that we have to accept that we're good and we know what we're doing, and so it's very minimal, but it does still happen.
I believe that's all we have for today.
Yeah,
Thank you for
cool.
your time.
Yeah, no problem, guys.
It's nice to meet you. So, I'm Keshley from the Eagles program. I'm going to
Hi,
ask you a
nice
couple
meeting
questions.
you. I'm Stefan from Mineralogy and Meteoritics.
It's nice to meet you. So tell me a little bit about these meteorites. What is the role that meteorites play on the creation of Earth?
So the material that's in the solar system now, today, started all out like the primitive material in these two meteorites here, number 1 and number 2. And through time and physical and chemical changes, they evolved to what we have today in the solar system. So when we are looking at those meteorites and others like them, we are looking at literally our forefathers. Everything that's in the solar system in terms of ingredients is in there. It only took time, physics, and chemistry to end up with you and me and everything else in the solar system.
Wow, that's pretty interesting. So, what would the world look like if there were no meteorites?
I don't know, because I don't think there will be this world that we know and we are part of. So there are many other objects in the galaxy and in the entire universe. But meteorites have the benefit of bringing us very, very, very early solar system material. If there wouldn't be the material that's in the meteorites, there wouldn't be a solar system that we know it, that we have it now. There will be very different.
Wow, that's pretty interesting. So, what are unanswered questions about meteorites?
So, for instance, it's a question if the organic material that seeded life on Earth came from outer space or not. That meteorite number 2 there, that very dark one, that is very rich in carbon. And not only carbon as carbon in minerals like graphite, it's in there, or other diamonds, tiny diamonds are in there as well. But there are amino acids, over 70 amino acids that are the building blocks of life as we know it. And there is this hypothesis that life on Earth was seeded with material that came in from meteorites. So that's one big question. Is it that right? Or there was another way that the ingredients, the building blocks of life came to Earth or formed on Earth. So that's only one. I told you there are many, 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 many.
Wow. That was very interesting. Well, thank you for having us.
Oh, my
It was
pleasure.
very nice.
Anytime.
And that leads off with our conclusion. Meteorites are more than just rocks in space. They are ancient messengers that tell the story of our solar system's origins. By studying them, scientists gain valuable insights into the formation of planets, the history of our own Earth, and the potential for life beyond it. Meteorites remind us that even small objects from the cosmos can have a big impact on our understanding of the universe. Thank you for exploring the fascinating world of meteorites with me.